Hello and welcome to another streaming time where we're going to go through some questions. So, it is 5 o'clock as promised, and I said today we would look at some questions. But before we do this, I should probably post the link again onto the classroom. Now, here is my Twitch. Hang on. How do I find the link? There is me streaming in the stream. Okay, hold on. Channel. That might help. Channel. That might help. Nope, that's just me. Channel. Nope, that's just me. Now it's just like repeating. Okay, this is a smooth bit of production. This is. Can I just copy the link from yesterday? That'll do. Let's just copy the link from yesterday. Can I just put it in there? I don't know. I'll just edit it. I should have put it in there as I went in, but there we are. You live and learn. Add link. Okay. Oh, hang on. Add link. Save. There we go. There's now a link. Here we are. We've got a link. Nice. Okay. Let's kill a bit of time. Let's do some questions. So we're going to look at Group 7 today. Okay, we've got Group 7 questions. So we did Group 1 yesterday. That video's gone on to YouTube. Okay, so you could just go through those questions in your own way. We're just going to look at these today. What I'm going to try and do today, I'm going to try and do a bit of cheesy COVID style. Okay, where I'm going to try and leave a little pause to give you a chance to answer. We'll see how that goes and if I remember to do it. So, this question here is about gases. Lovely. Some damp litmus paper is placed in a gas. The litmus paper is bleached. Which gas bleaches damp litmus paper? Is it carbon dioxide, chlorine, hydrogen, or oxygen? Say your answer now. Yes, well done. You said B, didn't you? Because it's chlorine. Okay. Great. I mean, this is about halogens, so obviously it's going to be the halogen. Right, some questions might be answered. Okay, this question is about Group 7. Which halogen is a green gas at room temperature and pressure? Wow, okay, so which one is a green gas? It is... You said B, didn't you? B would be correct. Am I getting a little bit cheesy for you here? Got to remember that this is a brown liquid. Okay, this is a very pale gas. Okay, and this is a purple solid. Boom. Right, here we go, a bit of a righty question now. The elements in Group 7 periodic tables are known as the halogens. Explain why chlorine is more reactive than iodine. Right, so this is, again, this is about electrons. It doesn't say it, okay, but this is about the electrons. So what we've got to say, the outer electron shell. Is it for iodine? Is it closer or further away from the nucleus? Brilliant. Is further from nucleus. Okay. So, does that mean there's a strong attraction or a weak attraction to the nucleus and those outer shell electrons? It means it's a weaker force of attraction. Force of attraction between outer shell and nucleus is weaker. So what does that mean? What's iodine going to do? It's got 7 in the outer shell. Is it going to lose 7 or gain 1? Yes, it's going to gain 1. Okay, so it doesn't gain an electron as easily. Okay, now, so that explains why iodine is less reactive. If you were to say the exact opposite of all of that, Say the outer shell electrons are closer to the nucleus. The force of attraction between the outer shell electrons and the nucleus is greater. So it does gain an electron, or gains an electron really easily. For chlorine, you would of course get all the marks there as well. Okay, next it says a piece of burning sodium is placed into a gas jar containing chlorine, as shown in figure 5. Look at that. At the end of the reaction, the inside of the gas jar is coated with white crystals. What could that be? Well, we've got sodium and we've got chlorine. That's all that's there. So what is it? That's right. It's sodium chloride. Boom. Science. Thank you, Benjamin B, for contributing. Science. Here we go. Feel free to, you can always contribute, guys, if you want to chip in, ask things, say the answers, generally be awesome, as you are, Right, hydrogen chloride gas and sulfur dioxide gas are separated in test tubes of water. Blue litmus is dipped in each test tube, okay? State the colour change you would observe in each test tube, okay? If these two things were added to there. Right, so HCl, aqueous, hydrogen chloride gas dissolved in water, better known as hydrochloric acid. Okay, that means the blue litmus will turn what colour? That's right, changes colour because of science, and it's an acid. Thank you, Benjamin. This is an acid, so the blue litmus paper turns red because HCl, AQ, is an acid. Brilliant. Rainbow. Excellent. Thank you. There's a whole series of colours here. Brilliant. Right, now, sulfur dioxide gas, okay, SO2 and AQ, dissolve that in water. Again, dissolves in water. Think about what? Think about the atmosphere topic. Sulfur dioxide is bad because it dissolves in the rain and causes what? Acid. You're saying rain, aren't you? It causes acid rain, okay? So that again, blue litmus paper turns what colour? It's an acid, so it's going to turn, that's right, it turns red. Close, Ben, close, Ben. It turns red, not pink. That's you think the phenolphthalein alkalines there. Right, this is because SO2 AQ is an acid. I'm loving the contribution here, Benjamin, I really am. Right, okay, the elements in group 7. Do I remember you? I do not. I was your favourite. That obviously narrows it down quite a lot. I have so many favourites. I don't have any favourites. They often say, do you have favourites? I don't. Benjamin Blizzard. I'm trying to remember. Was this at the Chase? I think it was, wasn't it? Anyway, I'll get on with my revision session while you think about that. The elements in group 7, yeah, there we go. The elements in group 7 of the periodic table were known as the halogens. I did a great job on science with Benjamin there. Clearly you can tell. Right, known as the halogens. Sodium also reacted with bromine. Write the balanced equation for the reaction of sodium and bromine. Okay, so we've got sodium, okay, plus bromine. Now remember, bromine being a halogen is Br2. Okay, now when sodium and bromine form a compound, it will just be NaBr. Think sodium and chlorine, NaCl. Okay, so now we've just got to balance this. So on this side we've got 2 bromines, on this side we've got 1 bromine. So I need 2 of these. That now gives us 2 bromines. But I've now got 2 Nas. I've only got 1 Na here. So I put a 2 in front of that, and I've now got 2. Fantastic. Balancing equations. I forgot to do the gap there. In another experiment, the student adds colourless sodium bromide solution to chlorine. Okay? Chlorine water. What would you see? Remember, this is a displacement reaction. Okay? So is chlorine more reactive than bromine? Yes, it is. Fantastic. So it will displace it. And what you will see is a yellow, orange liquid, which is bromine water. Okay, fantastic. Right, the ionic equation for the reaction between sodium bromide and chlorine is below. Explain which species has been oxidized. Now, we remember here from our oil rig, oxidation is loss, reduction is gain. Okay, we remember that oxidation is loss of electrons. Okay, we've got a negative ion here. It's not a negative ion, it's not negative anymore, meaning that one. Okay, now remember, those are bromide. It says up there, bromide. Bromide ions, okay, they lose electrons. Okay, so the bromide ions lose electrons. So 1 mark for each of them. You can, if you want, just say Br minus. That's a bromide ion. Okay, you can just say Br minus. Right, where are we next? Let's keep going. Oh, Bonnie, these pages just keep going, don't they? So, this is another question about halogens. Okay, bromine, chlorine, and iodine all react with heated iron wool. Figure 9 shows the speed of these reactions. Right. Immediately you can see this is getting slower. Okay, it's getting slower. You can just see that from there. When iron wool is heated with chlorine, iron chloride is formed. Write the word equation for this reaction. Okay, so you've got iron reacts with chlorine, and what does it form? Iron chloride, exactly. All of that is in the question. Seriously, it's all there. Give the name of the halogen in figure 9 that is the most reactive. It's chlorine, because it reacts the most quickly. Okay, very simply, reacts the most quickly. Now, it says 34.4% the mass of iron chloride is iron. Okay, calculate the mass of iron and the mass of chlorine in 125 grams of iron chloride. So basically, if 34% of it is iron, can we work out how much, essentially, 34% of this is? Okay, so what we do here is we do 34.4 divided by 100 and then times that by 125. Okay, and that gives you 43 G of Fe. Okay, so that's 43 of Fe. Now for chlorine, 125 is the total, minus 43, that equals 82. Okay, so the mass of chlorine is 82. Both of those added together make 125. Excellent. Okay, here we go. Fluorine, chlorine, bromine, and iodine, and acetylene are elements in group 7. Describe the test to show that a gas is chlorine. What colour litmus paper? There we go. Damp blue litmus paper turns red, then bleaches white. Sorted. Right, next. Complete the balanced equation. Lovely. Now, please note, you don't do anything with the F. They don't ask you to do that. Okay? So here we have 2 F's on this side and we have 1 on this side. So what do I need to times 1 by to make it 2? I times it by 2. I now have 2 F's. What about the K's? I all of a sudden have 1, and now I've got 2 times 1, which is 2. So I put a big 2 in front of there. Now you get 2 marks for that. You've then got to do the state symbols. Okay? So you've got to know the state symbol of potassium metal. It's a solid. Okay? You've got to know the state symbol of potassium fluoride. Now, do you know that? Probably not. Does anyone know that? Most people probably don't. But there's a big clue in the question. Namely in this statement that says potassium fluoride is a solid. That's not a clue. That's giving you the answer. Write an S in the brackets. Right. Aluminium reacts with chlorine to form aluminium chloride. Write the balanced equation for this. I'm going to scroll down a little bit more here so I can get a bit more room underneath it to do the balancing thing. So, aluminium, as we know, is just... Why is that so thick? It's just found as Al. Chlorine is found as Cl2. Okay. And we've got to work out there. Remember, Al3 plus Cl minus, meaning that 3 is going to go down there. We're going to end up with AlCl3. Okay. Part of the reason you get so many marks for this is because you've got to remember that. Now, let's start with the chlorines. Okay, we've got 2 and 3. Now, very difficult. How do you put those together? You make them both 6. Okay, so you times that one by 3 to get 6 chlorines. It's the first thing in common. Times that one by 2 to get 6. Okay, now how many aluminiums you've got here? Now you've got 2 times 1, which is 2. Over here, just 1. So what big number am I going to put in front of this one? Tell me. Yes, that's right. It's a 2. Fantastic. Well done. That's a particularly tricky balancing. To be fair, that's about as difficult as it gets. Okay, fluorine, bromine, chlorine, iodine, and acetine are elements in group 7. They all dissolve in water to make aqueous solutions. Potassium iodide is added to each of these solutions. Okay, now this is a displacement reaction question. Okay, and it's asking you to interpret these results and say what is going on. Okay, now you've got to remember that a more reactive halogen is going to displace a less reactive halogen. Okay, now this one is the least reactive, this one is the most, and this one is in between. So they've mixed the table a bit to confuse you, but essentially this is the least reactive and this is the one in the compound. So essentially both of these are going to displace it. Okay, so you could say that the iodide in potassium iodide, okay, is displaced in 2 reactions. Br and Cl are more reactive than I. Okay, that's why it's displacing it. Okay, the brown colour is the displaced iodine. Okay, now the last thing you've got to say is about this last one. Okay, in the last one nothing happens because I2 will not displace Ki, because they're the same. They're the same thing. They're not going to react. They're not going to displace each other. Okay. Right, question 12. It says, chlorine, bromine, iodine are elements in group 7 of the periodic table. A reaction occurs if chlorine solution is added to sodium bromide. Give a reaction. This is directly linked to the question we've just done. It's a displacement reaction because chlorine is more reactive than bromine. That's why it happens. Right, this next one involves you reading off a graph. It says, using figure 14, give the boiling point of bromine. Okay, now it's not, the scale is not fantastic, but you've just got to give a number there that's somewhere in and around where it is. So it's basically, it's a little piece above 50. Okay, it's not quite the 100. I would say a nice round number there would be about 60. Now, looking at the mark scheme, okay, give me a second, I'll just get the mark scheme up. Okay, looking at the mark scheme, it tells you that actually any number between in the range of 51 to 70 there would be fine. Okay. State which two elements are solids at room temperature. Okay, so basically they haven't melted yet at room temperature. Okay, so which two are the melting points quite high? That's iodine and astatine. Brilliant. Oh, I went the Welsh there. Right, what do we have next? There are quite a lot of these halogen questions. They're getting very samey, but let's just keep ploughing through them. Right, number 14 says, when a solution of bromine is added to sodium iodide solution, a reaction occurs. Again, look, it's a displacement reaction. The bromine has kicked the iodine out, okay, and formed iodine. Give the name of the substance causing the brown colour. That's the iodine. Now, which one has been reduced? Okay, now remembering oil rig, which we do, we remember that reduction is gain. Okay, and actually what we've got there, okay, we've got Br gaining an electron to form Br minus. Okay, so basically the bromine is reduced because it gains an electron. Okay. Now, which of the following rows gives the colour of group 7 elements, chlorine and bromine, at room temperature? Okay, now, got to remember there, got to remember the colours. Now, as you go down group 7, they essentially, the colours get darker. Okay, so chlorine is actually yellow-green. Okay, now, bromine is next, and iodine is last. Iodine is the grey one you can see there. Okay, so this is red-brown. Those are the colours. So actually the correct answer there would be C. Okay, next it says, which row in the table shows the colours and physical states of the elements at room temperature? Okay, so iodine, purple gas, nope, it's a solid. Chlorine, pale green gas. Iodine, brown solid, nope, it's a liquid. C, bromine, red-brown liquid, good. Chlorine, yellow liquid, nope, it's a green gas. Iodine, dark grey solid. Bromine, red-brown liquid. Yep, D is the right answer there. Okay, now look, more physical state stuff. Okay, hang on a minute. I've missed one out there. No, I have not. Okay, it says question 17. Using the melting and boiling points of bromine and iodine, using the information, which row shows the physical states of these elements at 50 degrees C? So, at 50, will this have melted? Yes, it would have melted at 50. Will it have boiled? Okay, no, it won't have boiled at 50. Is this going to have melted? No, and no, obviously. So this would be a solid, and this would be a liquid. Okay, so what we're obviously going to say there is D is the correct answer. Figure 13 shows the halogens in order in which they appear in group 7 of the periodic table. The melting points for the halogens are given. Estimate, so have a sensible, mature guess at the melting point of iodine. Okay, so looking at it as you can, okay, they are going up, I don't know, about 100 a time, possibly. Okay, so if you were going to estimate it, I would say any number, roughly, I'd say 100, 150 up would probably be good. Okay, so we'll just go with 150. Okay, now looking at the mark scheme, just for clarity here, it says any value between 20 and 301 would be fine there. So any number you said would be, remember, it's estimating. You don't know, okay? Bromine reacts with heated iron. Give the name of one halogen that would react with iron more vigorously than bromine. So you need a more reactive halogen, okay? So, as you go down here, do they get more or less reactive? They get less reactive. Well done. Okay, as you go down, they get less reactive. So, all you've got to do is name either this one or this one in your answer. I'm going to write chlorine. Okay, if you'd written fluorine, you would have been correct as well. Either of those two would have been fine. Okay. Right, question 19. Describe what is seen. What do you see? Do you see the way they emphasize the seen? They don't want to hear about atoms and elements and electrons and reduction and oxidation or anything like that, because you don't see that, okay? What do you see, okay, when the potassium bromide solution is reactive with chlorine water? Now, we remember that essentially the chlorine is more reactive, so it will displace the bromide from potassium bromide. You're not going to see any of that unless you've got really good eyesight, okay? What you're going to see, okay, is you're going to see essentially a colourless KBr solution turn orangey brown. That's what you're going to see. Okay, the colourless KBr solution will turn orangey brown. That's what you'll see. You put the chlorine water in the colourless KBr solution and it turns orangey brown. Describe what you would see if damp blue litmus paper is placed into chlorine gas. Okay, the litmus paper turns red, then bleaches white. That's the 2 marks there, okay? 1 mark turns red, 1 mark for bleaches white. Okay, now if you just remembered the bleaches white, you'd still get the mark for that. Okay, so it's all good. Okay, if you just said goes white, bleaches white, you get 1 mark. If you go this the wrong way round, they're going to give you nothing. Okay, rather harshly. Right, let's have a look. See, this is almost. We've got another row and I think a single page. When the gas hydrogen chloride is dissolved in water. Oh my god, I've gone all nasally, haven't I? When the gas hydrogen chloride is dissolved in water. I've gone all like that. Anyway, I'll try and be a bit more enthusiastic. A solution forms. Blue litmus paper dipped in the solution turns red. State why the litmus paper turns red. Okay, that's because HCl AQ is acidic. That's why it turns red. Right, fluorine, chlorine, bromine, iodine and astatine are elements in group 7. There's a trend in the colour and the state of the halogens at room temperature. There is. As you go down, the colour gets darker and the state goes from gas to liquid to solid. So, you need to say, obviously, the state's going to be a solid. Okay, because iodine is a solid. So as you go down astatine to below iodine, it's got to be a solid, right? You then need a darker colour. Remembering that iodine is grey, okay, you then need a darker colour than grey. So I would go with black. That's a darker colour than grey. Or, you know, really dark grey, just say black. Okay, black is a good one. Right. Chlorine, bromine and iodine are elements in group 7 of the periodic table. Chlorine is toxic. State one safety precaution that should be taken when using chlorine in the lab. Use a fume cupboard. Fume cupboard. You know that thing next to my board that I say I'm only there to fart in? No, it's a fume cupboard. It's there for chlorine. And it didn't work last time we tried to use it. Fun. Right. State the name given to the group 7 elements. They are called the... Yes, they're called the halogens. Fantastic. Okay. You then need to name the other elements in group 7 that isn't fluorine, chlorine, bromine or iodine. Use the periodic table on the back of your exam paper to help you. So basically you need to look at that and you need to write the word astatine on there, because that's the one below iodine. That's on the periodic table you've got in front of you, not hard. Right, which element is a liquid at room temperature and pressure? Now, we weren't allowed to do the chlorine thing because my fume cover was broken, but if we did it, you would have seen that bromine is a liquid at room temperature and pressure. Which element is dark grey at colour at room temperature and pressure? That would be iodine. Right, it now says bromine reacts with hydrogen to form hydrogen bromide. Hydrogen bromide dissolves in water to form a solution. Give the name of the solution form. Now, you may or may not know this, okay? You will remember that when HCl gas dissolves in water, it forms hydrochloric acid. Now, this does the same thing. It's going to be hydrobromic acid. Job done. Right, 26. What have we got here? Write the balanced equation for the reaction of chlorine with hydrogen to form hydrogen chloride. So, let's just do this. Chlorine is a halogen, is found in a pair. So it's Cl2. Okay. Hydrogen is also found as a pair, H2. That's going to make HCl. Right, we've now got to balance it. Okay, now please note you've got 2 out of 3 just for writing that. Balancing is mark number 3. Okay, so on this side, to start with chlorine, we've got 2, we've got 1. There's only 1 chlorine there. What do I need to multiply 1 by to make it 2? The answer would be, you tell me. Fantastic, the answer is 2. I stick a big 2 in front of there. I've now got 2 chlorines. Let's count the hydrogens. We've got 2 over here, and we've got 2 times 1. 2 times 1 being, that's right, it's 2. That's now balanced. Well done, guys. You guys are getting this. Ooh, penultimate page. Another balanced equation. Fantastic. It says fluorine reacts vigorously with iron to produce iron 3 fluoride. Now, a quick bit about this, just because, okay, iron 3 fluoride contains an iron 3 plus ion. Okay, ion. That 3 relates to the charge of the ion. Okay, iron 2 fluoride would contain an iron 2 ion. Okay, that Roman numeral there tells you the charge. Brilliant. So, but it tells you the formula bit anyway. FeF3. Right, so you just got to write a balanced equation for this. Now, iron, as we know, iron, the metal, is found on its own. Fluorine will be found as F2, and that makes FeF3. Okay? Right, so let's do this. Let's start with the F's. So we've got 2 and we've got 3. Now, what do we do with this? What have we got to do? We have got to change it, okay, to make these both 6, okay, because that's the first common multiple of 2 and 3, isn't it? So I've got to times that by 3 to make it 6, and I've got to times that by 2 to make it 6. Okay, we've now got the same number of fluorines on both sides of the arrow. Now, I've now got Fe's, I've got 1, and I've got 2 times 1, which is 2. So what do I need to times this by to make it the same as that? What do I need to times 1 by to make it 2? That's right, the answer is 2. Job done. That's the equation balanced. Okay, our final page. Please note, no 6 marker in this lot, which is interesting, shall we say. Right, chlorine, bromine, iodine are elements in group 7 of the periodic table. Chlorine reacts with hydrogen to form hydrogen chloride. Write the word equation for this. Hang on, they've literally told you. Chlorine reacts with hydrogen. Yep, they're both there. To form hydrogen chloride. All in the question. Right. Hydrogen chloride dissolves in water to form an acidic solution. State what is seen when blue litmus paper is dipped in solution. It turns red. Fantastic. Now we've got to draw some electrons. Joy. A chlorine atom has 7 electrons out of shell. Hydrogen atom has 1 electron out of shell. Okay, now I'm going to say, just for fun, the X is the hydrogen electron here, and the dot can be the chlorine. Okay, so there's 1 X as there should be. I've now got to fill in this outer shell with enough dots to make 7 dots in total, which, as we can see, is that. That's 1 mark. Now, what type of bonding is involved here? Well, this is a shared pair of electrons. Woo! So it's covalent. Let's just go with that and pretend that's true. It's covalent. It's true. It's totally covalent. Absolutely covalent. I'm not lying to you. Anyway, it's covalent. You've got to say it's covalent here, okay? Don't worry about that. It's covalent. If you want to know any more about that, do A level and ask Miss Hammond. Anyway, that's the end of that. That's the end of the paper. We've now done the group 7 questions. Now, before we go, I will pop this up, okay, on my YouTube channel, which is under the guise of Professor Pike. That's me, okay. There are several revision videos, okay, which I've made. Some lessony kind of ones. I did tinker once in a while with the idea of putting my lessons on here and just playing myself going through worksheets. It was a good idea, but I ran out of time to make them. I think I start marking exams at that point. Yeah, there are a load of videos, me going through papers, and there's my old gaming ones, just ignore those. There's a load of stuff of me going through things. I am slowly but surely adding to these as time goes on. Feel free to have a look at those. Anyway, I'll stick this one on there right now. You guys have fun, and I will see you very soon.